Hi everyone! Today we are going to be continuing our lesson on how to graph a parabola. Let's begin by reviewing how to graph by looking at this equation that has all the four different types of transformations that we have already learned. So y is equal to negative a half bracket x plus 5 squared plus 3. If you take a look at the negative, you are going to remember that a negative over here means that our parabola is going to open downwards. So a regular parabola with a parent function of y is equal to x squared opens upwards and looks like a U, but in this case, our parabola is going to open downwards. Then we have the number 1 over 2, and that tells me that this has a vertical compression because when the number is between 0 and 1, that tells us it's a compression, and our parabola is going to be wider than the parent function of y is equal to x squared. So the way that we deal with a vertical stretch or a vertical compression is we begin with our numbers, our regular old step pattern of 1, 3, and 5, and we multiply those numbers by whatever the number is for our stretch or compression. In this case, it's a half. So I'm going to multiply 1 times a half, and that's going to give me a half. 3 times a half, oops, sorry, is 3 over 2, which is the same as 1.5. And 5 times a half is 5 over 2, which is the same as 2.5. So now when we are graphing, our new step pattern is going to be a half, 1.5, and 2.5. Okay, let's continue looking at our equation. X plus 5 tells me that there is going to be a horizontal translation, and we are going to be moving our parabola 5 units to the left. Remember, this is counterintuitive, which means if the number inside the bracket is plus, you're actually moving to the left. And then finally, we have a positive 3 here, and that tells us we are going to be moving our parabola 3 units up. Okay, so we begin by figuring out where the vertex on our graph is going to be. And to figure out the vertex, you only need these two pieces of information over here, 5 to the left and 3 units up. So let's figure out where that would be on our grid. Starting from the vertex 0, 0, or starting from the origin 0, 0, you're going to go up 3 units, and then you're going to be moving 5 units to the left, and you're going to make your point over here. So clearly our vertex is going to be negative 5, comma 3. Now, we know because of this negative sign over here, our parabola is, sorry, this negative sign over here, our parabola is going to be opening downwards. So we're going to go 1 to the right, and then we're not going to go up, we're going to go down. And how much are we going to go down? Well, we need to look at these numbers to figure that out. So we're going to be going 1 unit to the right, down a half. And it's going to be a little bit hard. Hopefully yours on paper is going to be a little bit easier to draw. There we go. Then I'm going to go 1 to the right, down 1.5, and 1 to the right, down 2.5. 1, 2.5. Okay, same thing on the other side. 1 to the left, down a half, and then 1 to the left, down 1.5, and then 1 to the left, down 2.5. And then we are going to join all of our points together, keeping in mind that our parabola should be looking a little bit wide as it does, because this is a vertical compression, which is squishing our parabola, so it's expanding a little bit. Now, you want to make sure you always put the equation y is equal to negative a half bracket x plus 5 squared plus 3. Hopefully you guys did the 10 graphs that were assigned and have gotten lots of practice on graphing and are experts at this by now. So the purpose of today's lesson is to look at the different features of a parabola again, but this time we're going to be using the graph as well as the equation. So I want to show you the cool features you can figure out using both the graph and the equation. We're going to begin with the vertex. We know the vertex of a graph is the point that's the highest or the lowest. So in this case, it's this point right over here, and that is negative 5, comma 3. So we can very clearly see it on the graph. It's negative 5, comma 3. But let's say we didn't have the graph. How can you figure it out from the equation? Well, to figure out the vertex just from the equation, you take the number inside of the bracket and you change the sign. So if it's a positive 5, the vertex is actually going to have the opposite sign. It's going to be negative 5. That's your x value. And your y value ends up being this number over here, which would be positive 3. So it's very easy to see it from the graph, but also from the equation. You can determine it by looking at the number inside the bracket and changing the sign. That's your x value, and then your y value is the positive 3. Next up, we look at the direction of opening. In a graph, it's very, very easy to see that this parabola opens downwards. But what about if you didn't have the graph and you only had the equation? In order to figure out the direction of the opening, you have to look at this sign over here. If the sign is negative, that means the parabola opens down. So negative means it opens down. And if that number is positive, the parabola opens upwards. So in this case, both the graph and the equation tell us that our direction of opening is down. To figure out the step pattern from a graph, what you want to do is you want to follow it along. So for example, I start at my vertex, I move 1 to the right, and then I can clearly see the next point is this one over here. I've moved down a half. Then that gives me the biggest clue that my step pattern is not 1, 3, and 5, but I have multiplied those numbers 1, 3, and 5 by something to give me an initial value of a half. And in this case, it ends up being a half. You do need a little bit of practice looking at different graphs and figuring out what the step pattern is from a graph. But the easiest way is just go 1 to the right and see how much you're going down. And that number is basically the number that you are multiplying your step pattern by. In an equation, it's pretty straightforward. Your step pattern is whatever this number is here over here. And again, you're multiplying that by 1, 3, and 5. So to get our graph, we went a half, and then we went 1.5, and then we went 2.5. And you saw that in the previous slide. Okay, so in earlier lessons, you guys learned that the axis of symmetry is the line that splits the parabola in half and makes it symmetrical on both sides. So in a graph, you can just draw a line that goes down the vertex, and whatever point it passes through, that's your axis of symmetry. So in this case, it ends up being x is equal to negative 5. But how about from an equation? How do we figure out the axis of symmetry from an equation? Well, what you do is you look at the bracket and you set this term equal to 0. So you're going to go x plus 5 is equal to 0, and then you solve for x. So x is equal to negative 5. And you're going to notice you get the exact same answer. So from an equation, it's pretty straightforward. Make a line going down the vertex. And from an equation, you take the term inside of the bracket, set it equal to 0, and solve. And either way, you're going to get that the axis of symmetry is x is equal to negative 5. Moving on to maximum and minimum. When the vertex is as high as it can be, like in this example, that would be an example of a maximum graph. And if the parabola looked the other way, like this, it would be an example of a minimum. So this is a maximum. How could you tell that from the equation? Again, you have to look at this sign over here. A negative sign means your parabola is going to open downwards, and it's going to have a maximum vertex because it's an upside down parabola. Okay, so we're going to write max. The other thing I'm asking for is the value where the maximum occurs. And to figure that out, I'm just going to erase this to make it a little bit clearer so we can see what I'm doing. Okay, so on an equation, what you're going to do is you start at your maximum and you go all the way to the y value, and wherever that hits the y-axis, that is the value where the maximum occurs. So in this case, and you have to write it in the format of y is equal to positive 3. So we would say this graph is a maximum at y is equal to positive 3. How do we figure out the maximum value from an equation? Very easy. It's this number over here. So if you're trying to figure out if it's a max or min, you look at the sign. A negative means it's going to be a maximum. Where does it occur? It occurs at this number, y is equal to positive 3. Okay, so to figure out the y-intercept, just like we've been using all along for lines and anything, we're going to let x equal to 0. And you could try to look on a graph, but it's often not going to be very obvious. Your best bet is to go ahead and use the algebraic method of solving this. So wherever I have an x, I am going to put in a 0, and I'm going to solve. So I'm going to get negative a half. 0 plus 5 is 5. 5 squared is 25 plus 3. This is going to be negative 25 over 2, and I'll just find a common denominator. So it's going to be 6 over 2, and I end up getting negative 19 over 2, which is very hard to visualize. So I am going to change that answer to a mixed fraction, which is going to be negative 9.5. So I believe that our y-intercept is at 0, comma, negative 9.5. Just to confirm, I'm going to go back to my graph and see if I can kind of see that. And, if you look very closely, you can notice that the line crosses the y-axis at approximately 9-ish. It's very hard to tell, but our calculation of negative 9.5 is probably correct. Actually, it is correct. To solve for the x-intercept or the zeros, from a graph, if it is very obvious, you can just read it off. But in this case, unfortunately, we can't see exactly where it occurs. So we're going to have to, again, rely on algebra to figure it out. We're going to let y equal to 0, and we're going to solve. Now, this calculation ends up being a little bit more complicated, but I'll go through it with you guys. So the first thing I want to do is I want to open up these brackets by using FOIL. And when I do that, I end up getting x squared plus 10x plus 25. Make sure you're using the proper method. So this would just be like saying x plus 5 times x plus 5. And you're multiplying the outer numbers, the inner, the first numbers, the outer numbers, the inner numbers, and the last to end up getting this trinomial here. And then we can't forget about the positive 3. I'm going to go ahead and distribute the negative a half into the bracket. So I'm going to get negative a half x squared minus 5x minus 25 over 2 plus 3. I don't really like having fractions around, so I'm going to go ahead and multiply everything by the magic number of 2. And when I do that, I end up getting negative x squared minus 10x minus 25 plus 6. And let's just clean that up a little bit. It's going to be negative x squared minus 10x minus 19. And I want this to look like a trinomial. So I'm going to factor out the negative sign. It's going to be x squared plus 10x plus 19. All right, so we learned from a couple of weeks ago when we were learning how to solve quadratic equations that you can actually solve for x by trying and factoring this. This is a simple trinomial. You try different factors, and you would go ahead and do that. But trust me when I say that this is actually not factorable. You're not going to be able to get 2 answers. So now what we're going to do, if you can't figure out the factors by traditional method, is you are going to be using the quadratic formula, and that's what I want to talk about. So keep in mind our quadratic formula is your a value is whatever is attached to the x squared, your b value is whatever is attached to 10, and your c value is whatever is attached to which is the constant. And our formula is x is equal to negative b plus or minus b squared minus 4ac over 2a. And I'm going to cheat a little bit and skip steps. It is advised that you don't do this, but when you go through this whole entire procedure, put in the numbers and solve for it, you're going to get that the x values are x is equal to negative 7.4 and x is equal to negative 2.6. And we can verify if that's true on our graph by this looks like it's between 2 and 3. And this looks like it's between 5, 6, 7, and 8. So these numbers seem very accurate, which means our x-intercepts would be negative 7.4, 0 and negative 2.6, 0. Now, there are going to be some cases where when you come to this step over here, you're going to get a trinomial that is factorable, and that saves you a lot of time. And often in that case, you can also see the x-intercepts from the graph. But there are going to be um, situations where you're going to have to use a quadratic formula, get out your calculators and solve and get those two decimal places because that's the correct answer. So if you haven't already done so, we can now fill in the rest of the chart. The y-intercept is 0, comma, negative 9.5, and the x-intercepts are negative 7.4, comma, 0, negative 2.6, comma, 0. So your task for today's lesson, you have created 10 graphs from the previous homework assignment. What you're going to do is now you're going to go to each of those graphs and you are going to do exactly what I did, answer all of these questions for every single graph. You can either use the graph or the equation or sort of practice doing both. And try not to get lazy for the x-intercept. Some of them will require the quadratic formula. Practice doing it. All the answers are there because practice makes perfect. Bye, guys.